Good evening everyone, myself Charan from CSC department. Today I am explaining about the topic given in the data structures and algorithms. My topic is implementation of stacks using arrays in C. Moving to next slide. First of all, introduction to stacks. A stack is a linear data structure that follows the last in first out principle. That means LIFO principle, and it allows operations such as push, pop, and pick. Push means to insert an element at the top of the stack, and delete, and pop means to delete the element at the top of the stack, and peek means it is nothing but to display the top of the element in the stack. Understanding stacks is important for various algorithms and applications in computer science and engineering. Moving to next slide. And next, characteristics of stacks. Stacks have a dynamic size and limited by the size of the array used to implement them. The main operations are used to add a push to add an element into the stack, and pop to remove the top element. Stacks are used in function calls, expression evaluations, and backtracking algorithms. In stacks, the main important operations are push and pop. Moving to next slide. Stack operations. Stack operations. The push operation adds an element to the top of the stack, and the pop operation removes the top element and returns it. The peek operation returns the top element without removing it from the stack. Moving to next slide. Stack implementation using arrays. An array is used to store stack elements in a contiguous block of memory. A variable tracks the index of the top element in the stack. The maximum size of the stack is defined at the beginning of the implementation. It is defined at the beginning of implementation. Moving to next slide. And next, defining the stack structure. A stack can be defined using a struct in C that contains an array and an integer for the top index. The struct typically includes a size attribute to indicate the stack's maximum capacity. This structure allows easy management of stack elements and their count. Mainly push operation in C. First of all, the push operation checks if the stack is full before adding the element. If the stack is full, add an element. If there is space, it increments the top index and assigns the new element, that means plus 1. And this operation ensures that the stack maintains its LIFO principle, that is last in first out property. Moving to next slide. And the next slide, pop operation. The pop operation is to delete an element in the stack. The pop function checks if the stack is empty before removing an element. If not empty, it returns the element at the top index and decrements the index, that means -1. It comes to below of the size. This operation also maintains the integrity of the stack while following the LIFO principle, that is last in first out principle. Moving to next slide. And peek operation in C. The peek operation retrieves the top element without modifying the stack. That means it displays the top of the stack element without modifying the stack. And it checks if the stack is empty to add accessing invalid memory because there is no element in the stack. And this operation is useful for examining the top value without altering the stack state. That is, the top value displays the peak in the peek operation. And moving to next slide. Example code for stack implementation. A simple C code snippet can illustrate the stack operation effectively. The code includes definitions for push, pop, and peek functions. This example serves a practical reference for implementing a stack using arrays. Moving to next slide. And applications of stacks. Stacks are widely used in recursive algorithms and parsing expressions. That means recursive algorithms means the function call by itself is called recursion. They are essential for managing function calls and local variables in programming languages. Understanding stacks. helps in optimizing memory usage and improving algorithm efficiency. They are essential for managing function calls and local variables in programming, and they are used in parsing expressions. Understanding stacks helps in optimizing memory usage and improving algorithm efficiency. Feel free to modify and expand any of the points as necessary. Thank you.